Okay, so in this video, I'm going to be speaking with Dr. Stephan Guyenet. Stephan has a PhD in neuroscience, and he's done research in areas related to the neuroscience of body fatness for 12 years. He's published many peer-reviewed articles in scientific journals in areas related to obesity and the brain, and he's the author of the book The Hungry Brain, which argues that it's actually our ancient instinctive brain circuits playing a survival game that's causing us to overeat in the modern food environment, not necessarily a lack of willpower or an incorrect understanding of what to eat. Now, many of you may know that Stephan was recently on the Joe Rogan Experience podcast, where he was debating what is actually causing us to get fat, and I think we elaborate on that discussion over here. So we talk about the calories in, calories out model of weight gain. We discuss whether or not a calorie is a calorie for weight loss purposes, and we talk about the role of carbohydrates and sugars in the obesity epidemic and how a lot of this is regulated in the brain. So we do cover a lot of ground in just over an hour, and I think this is a conversation that you guys are really going to learn a lot from. So without further ado, I hope you guys really enjoy this discussion about fat gain, models of obesity, and the brain with Dr. Stephan Guyenet. So guys, I'm here with Stephan Guyenet. Stephan, thanks for coming on. I really appreciate it.
My pleasure.
So for the context of the viewers, this is being recorded about a week after you were on the Joe Rogan Experience podcast where you debated Gary Taubes. So we're going to do something of a response to that. But I think what I want to do, if this is cool with you, is just really quickly recap how it was that debate was set up. And then we can kind of move forward with what I think are the more interesting areas that you guys touched.
Yeah, absolutely. So initially, Joe had Gary on to do a solo interview, and I think a lot of people who had read my work that is critical of Gary's work saw that, and they recommended that he interview me. And so I got in touch with Joe, and we talked about it a little bit, and then basically it fell by the wayside for a while. But what caused it to come up again is this guy named Kevin Bass on Twitter just started really agitating and saying that Joe essentially had a low-carb bias, and that everything he had about carbohydrate on the show was very negative, and that it would be nice if he had some balance and had some more evidence-based people on the show. I'm not saying everyone that he had was not evidence-based, but I would say some of them were not evidence-based. And so he started agitating, and he did this really interesting analysis. I'm still not sure how he did this, how he pulled it off, but he transcribed every word that every person had said in all of Joe's interviews and did an analysis on it, showing how many times they had brought up carbohydrate and whether that was positive or negative. Wow. And essentially it was all negative. Almost all of it was negative. And so, and so once Kevin did that, it really, to Joe's credit, it really got his attention, and he said, hey, maybe I should start having a little more balance here. And so eventually that led to an invitation for me to come on the show. And I think Joe has been enjoying the debate format, and so it turned into an invitation for me to debate Gary. And, obviously that kind of a scenario kind of gets more attention and gets people more fired up than just having somebody on solo.
Right, I gotcha. So I listened to the whole thing, so I don't expect everyone listening to have done that, but in case you have, I think we'll still build on what was discussed over there and clarify some stuff. Up front, I just like to do my best in 30 seconds to kind of summarize both of your guys' positions, and you can correct me if I get anything wrong. So essentially, as I understand it, Gary's position is that you have good calories and bad calories, and the bad calories are basically carbohydrates, and in particular refined carbohydrates and sugars. And it's their consumption that is causing us to get really fat. And calories don't matter all that much. They at least matter significantly less than carbohydrates do for getting fat. And I feel like that's actually a pretty accurate representation of what he has to say. You can correct me after, but that's pretty much the gist of it. And then I think your position is that calories actually matter a lot. In fact, they're the main thing that's driving the obesity epidemic and what is causing us to get fat in general. And then your background is in neuroscience, so you've kind of taken a slant where you say that, well, the brains that we're working with haven't yet evolved enough for us to be able to handle our modern food environment, where you just have this huge abundance of very delicious but also very high calorie foods, and that's basically causing us to overeat on it, and that's the reason we're getting fat. And you say carbs play some role in it, but they're not the main driver. Is that upfront kind of accurate?
Yeah, I think that's pretty accurate. I would maybe modify two things there. One of them is with Gary's model. He essentially doesn't think calories matter really at all. I mean, I think he would concede that, like, you know, if you're eating no calories, then that matters. Or if you're eating like super duper starvation level calories, then maybe that matters. But I think in general, he just thinks that thinking about calories or having that as a mechanism is just irrelevant. So then with my model, I think there's another element of it that's important to understand, and that's that obesity or leanness, differences in body fatness are not just caused by passive differences in calorie intake. So it's not like we're just, you know, one day waking up in the morning and saying, hey, I feel like eating more calories today. There's actually regulatory changes that are occurring in how the brain regulates body fatness that allow the obese state to occur and maintain it once it has occurred. And so, and this is where my model partially overlaps with Gary's model, is that we agree that people with obesity are not just lean people who are eating more calories. There's actually a regulatory change that happens in the biological pathways that regulate body fatness. And we can talk about how exactly that happens later. But the difference is that in my model, those pathways are acting via calories, primarily calorie intake. So that's the main way in which the brain regulates body fatness, is by regulating your calorie intake. And so my point is simply that it's not a passive process. It's not just however much we decide to eat, that these things are regulated via the brain circuits that regulate body fatness and determine our appetite and our cravings and those types of things.
Would you say that your position is the mainstream scientific consensus positioned, do most scientists agree with you or Gary?
So, you know, I hesitate to use the word consensus because getting scientists to agree on things is like herding cats. But I would say that at least within my field that studies obesity from a kind of energy balance and neuroscience perspective, that yes, that is the predominant view. And that I would say that not just in my more narrow field, but in the broader obesity field in general, there are very few people who accept Gary's model. And I would say you can find some, you know, for example, David Ludwig is a researcher at Harvard who agrees with Gary's model almost verbatim, but I'm not aware of anyone else really that does. There are other people who agree with like different versions of the model, like Robert Lustig, but his is more centered around the brain. There are other researchers who think insulin is important, like Jim Johnson, but he's not really buying into Gary's idea specifically. So I think there are really very, very few people within the scientific community that really buy into Gary's hypothesis. And I think people don't necessarily get that impression in the public from outside the scientific community, because the people who do believe it are super, super vocal. So they're making a lot more noise than the people who don't. And also when you look at popular health and nutrition writers, many of them do buy into Gary's model. And so I think people get the impression that there's this like raging scientific debate about this in the scientific community, but really there's not. I mean, I don't think there's hardly anybody who thinks calories don't matter. And the reason for that is because the evidence very strongly suggests that they do matter.
Yeah, at least in my circle of the internet, this seems like such a fringe position that it's just mocked endlessly. So coming into this debate, it's just like from my perspective, it almost feels like, you turn on CNN and you have one guy who's denying climate change on the one side, and then another guy, you have like Bill Nye on the other side. And it's like kind of obvious from a scientific perspective who you're listening to there. But I think it shows that disassociation between what might be mainstream in the scientific community is not necessarily mainstream in the general public at this moment on this issue. So I think it's a good thing that you got to go on Joe's podcast and talk about this stuff. But yeah, just to tip my own hand, I was familiar with a few of those guys that you mentioned, but from my position, actually before we came on the call here, I was reading your bio and I noticed that you're the director or maybe a research assistant for the Examine Research Digest. And yeah, I'm friends with Kamal. I've interviewed him 2 or 3 times, so we've got a few mutual friends there. And just being familiar with this work, it just feels like this is really not a very credible position within the scientific community. But as you said, I guess maybe there is some disagreement, but people who believe this are in the minority, you would say.
Yeah, absolutely.
Yeah.
And I really don't think it is a credible position, at least as articulated by Gary. I mean, and I hope that came across pretty clearly in the debate. Yeah, so I think that pretty much at every turn, when you actually sit down and ask the question, what predictions does this hypothesis make and how can we test those predictions, which that's just the scientific method, what I just described. When you actually do that and you look at the things that have tested those predictions, I mean, you find over and over again that those predictions are not supported. And I mean, we could talk about some of those things. I talked about some of them in the debate, but I mean, at some point, you can't just keep saying that all the evidence is garbage and you can't keep complexifying your hypothesis to, allow it to escape refutation. At some point, you have to say, okay, well, this is just not fitting the evidence that well. I need to find another hypothesis. Yeah. And I think that we're long past that point.
So as I was listening to the debate, one of the things that I noticed didn't come up a whole lot was the calories in, calories out model of obesity. So is this something that you subscribe to?
Yeah, that's a good question. And actually, I'm gonna turn the question around on you a little bit, because this calories in, calories out thing is a concept that people refer to a lot, but it can mean several different things. And so I'm never quite sure what people mean when they say that. So would you tell me what you mean when you ask that?
Well, I think it's the difference between, well, let me just put it this way. If you eat more calories than you expend, then you'll gain weight. If you expend more than you eat, then you'll lose weight. And ultimately, changes in weight come back to energy balance. That's as simple as I can put it forward. And I think it's true.
Yeah, and I think when you put it in that way, I don't think Gary would deny that either, because he acknowledges the first law of thermodynamics, which is that energy can neither be created nor destroyed. And if you accept that, then you can't deny that if more energy is entering your body and less is leaving, then the energy content of your body is increasing. So I think he actually accepts that. I think what he would say is that energy intake and energy expenditure are independent from one another, and so are dependent. So your energy expenditure depends on what you're eating. So, for example, if you ate extra calories from fat, maybe your body would just burn it off. Your energy expenditure would increase to compensate. You'd burn it off, and then it wouldn't end up in your fat tissue. Versus overeating carbohydrate, and your insulin goes up, the energy goes into your fat tissue, and your energy expenditure doesn't change or maybe even goes down. So I think that's kind of how he would conceptualize it. Now, of course, that's not actually what happens when you run the experiments, but I think that's what he would argue. So he's not arguing against the laws of physics, but he's arguing that what we're eating, the types of calories that we're eating, can affect the energy outside of the equation such that fat is not accumulating in fat tissue.
Mm-hmm. It seems a little bit hypocritical, though, for him to say on the one hand that calories don't matter for weight change, yet calories in versus calories out is what determines weight change. I mean, I feel like he's got these conflicting statements, and that's why I felt like if you could just ask him the question, you know, if you eat, and I actually don't know if he would sign off on the calories in, calories out model, because he's more or less said, you know, in his example with his brother that, you know, his brother overate by just as many calories as him and didn't gain any fat. And, you know, he gained a bunch of fat eating the same amount, or I forget exactly how the example went, but there are all these instances where he seems to cut almost directly against the calories in, calories out model. So from my perspective, it would have been very clear if you could have just like, for you to say, yes, the difference between calories in versus calories out is ultimately what's driving weight change, and this is determined mostly at the level of the brain. If Gary could sign off on the calories in, calories out part, then you could get, you know, move a little bit forward more easily with the insulin and fat cell regulation stuff. It seems like that's the most fundamental thing that you guys need to either agree on or disagree on.
Well, I think he has this kind of he's looking at it from a very different angle. So for him, the calories in and the calories out are not driving anything. Those are the outcome of what's happening at the level of the fat cell. And so that's kind of how he would respond to that. And so for his brother and him, you know, assuming they were eating identical number of calories, which we really have no idea, and neither does he, maybe he would say that because his brother had less of a capacity to store fat in his fat cells, the extra energy was burned off and not stored as fat. So his energy expenditure was higher. I think that's kind of how he would conceptualize. And again, I'm not defending this idea. I'm just trying to explain what I think he would say.
Mm-hmm. So as a matter of, you know, communicating this stuff to the public, do you think that it is a good idea to tell people that you should focus on, you know, eating less and moving more if you want to lose weight? In that sense, is the calories in, calories out model a good one?
Yeah, so I think this is exactly, I think this question plus your last question kind of puts its finger on where the confusion lies, because when people say calories in, calories out, sometimes they mean, you know, the question of whether energy balance determines body fatness, which it does, and sometimes they mean, is it all just about, you know, how much you decide to eat or move, and is counting calories the best way to affect your body fatness? And so that's kind of the perspective of the second question you're asking, which is the eat less, move more question. And no, I don't think that for most people that probably is the best way to affect their body fatness. And, you know, I know that your audience is a very physical fitness oriented audience. And so I think there are probably more people who are successful with kind of calorie counting quantitative approach. I know that's fairly popular in the physical fitness community. But I think for the average person, they're just not, they don't want to engage with it at that intense of a level. They just want to eat until they're full and stop eating and not be fat, basically. And so, and you know, you can't blame them. Like, that's how the human brain has interacted with food for as long as the human brain has existed. You know, our ancestors didn't have Excel spreadsheets where they were marking down how many calories they were eating and marking down how many calories they were burning. They had regulatory systems in their brains that would respond to signals of energy status in the body and food cues around them in the environment and naturally regulate their body fatness to the right level. And so, and generally, you know, those populations ancestrally probably had very low levels of obesity. And so, personally, I prefer, as a kind of like blanket general recommendation for the average person, I prefer to try to construct a food environment and a diet and a lifestyle for them that allows their brains to naturally regulate them to the right calorie intake and to the right body fatness to meet their goals. And so, and again, I'm not at all, I'm I'm not at all dismissing or discounting the value of actually counting and tracking calorie intake and expenditure. I think if that's something that works for you, then that's great. I have nothing negative to say about that if it's working for you. But I think for the average person, that's not the approach that's going to get them the greatest or the most sustainable results. Not because calories don't matter, but simply because that direct approach is, for the average person, not the most effective one for actually regulating your energy balance.
Yeah, so I guess there's two things there. So one is what is in fact driving changes in body weight and body fat. And then the other thing is how do you practically implement that so people actually lose body fat in the real world. So I personally think it's important to tell people that it's actually probably, in a practical sense, much simpler than you think it is, because you'll hear people like Gary talk about insulin and leptin and all this stuff that sounds very confusing, and then they have to avoid carbs and they have to cut sugar and so on and so forth. Whereas if you had scientifically credible people saying it ultimately does come down to calories in versus calories out, then you could design a plan, whether it be tracking calories or modifying the food environment or a meal plan or whatever, that could work. But the underlying science that's driving the positive body composition change would be well understood. Do you see what I'm saying?
Yeah, absolutely. And I agree with that completely. And I mean, that's my perspective, that the energy balance equation is really the most powerful driver of the changes we're looking for when we're looking for changes in body fatness. However, once it comes to implementing that, how do you change energy balance? That's where it necessarily has to become more complex. And I actually think this is one of the places where the low carbohydrate diet really succeeds, is in its simplicity, because that's something where you can say, hey, basically this one food substance or this narrow subset of food substances is the thing you need to focus on. Get rid of that, and you're automatically improving your energy balance. And so I think it's actually very simple, both for people to understand the model and to implement practically. And I think that's actually one of the advantages of it. But there are many ways to affect energy balance, and low carbohydrate eating is a valid tool for doing that. But I think there are other valid tools. And personally, I mean, my view is I'd rather not greatly restrict a macronutrient unless I really have to. I'd rather give my body all of the macronutrients abundantly, as long as I can control my calorie intake appropriately in that context. But I mean, it does, when you're giving your brain everything at once in terms of macronutrients, it becomes harder to control your calorie intake. So people who are right in the middle of the spectrum, where they're eating lots of carbohydrate, lots of fat, and lots of protein, that's the place where it's going to be more challenging to control your calorie intake. And so you might have to leverage other strategies, whether it is actively counting your calorie intake, or eating a lower calorie density diet, or eating a less palatable diet, or restricting your eating window, or some combination of those things.
I want to get to quickly the brain related stuff and food environment related stuff, but before we move on to that, I know that there will be some people listening who will still be very skeptical of the just energy balance in general, because it's not really well accepted in the mainstream. People either think it isn't true, because clearly there are cases where you'll gain weight even if you're not eating much, like say if you're stressed or whatever. And people are notoriously bad at knowing how many calories they're actually consuming. So there are all sorts of ways that this can seem to be obviously false, when in fact the literature tells us otherwise. So needless to say, there are definitely calories in, calories out, and energy balance skeptics out there. And in a conversation like this, it's difficult to communicate how this model can be correct, but yet still not capture everything there is to know about losing fat and how everything works at every level. So how do you deal with that sort of skepticism? How do you go about trying to convince people that it is energy balance that's driving changes in body weight and body fat?
Yeah, I mean, all I can do is point them to the studies. The problem is that energy balance is actually fairly challenging to measure. And so whether you're a person trying to track your calories or whether you're a researcher asking people how much they ate, it's actually really hard to get accurate answers. And so to get accurate answers, you have to look at data that was generated using accurate methods. Those methods do exist, but you have to go looking for them. And essentially, when you look at calorie intake in people of different levels of body fatness using accurate methods, and I'm talking about things like respirometry that measures respiratory gases to measure calorie expenditure. If you can accurately measure someone's calorie expenditure and their weight isn't changing, then you know what their energy intake is as well. That's first law of thermodynamics, conservation of energy. And so those are the studies that have most accurately measured calorie intake. And what you see is that as body fatness increases, calorie intake goes up. And basically it goes from lean level up by about 10% to someone who is overweight but not obese, up to about 20% for a person who just has mild obesity, and then all the way up to 35% for someone who has very pronounced obesity. And it's not because they have more fat, it's because they actually have more lean mass. So the more fat you accumulate, the more lean mass your body has as well. And that's the more metabolically active tissue that drives up both your calorie expenditure and your calorie intake. So you're at a new equilibrium where you're eating more and burning more, and that describes obesity. And this is very well characterized. This is not controversial within the scientific literature. Once you correct for height and sex and physical activity level, what I just described is what you see. So there's definitely an increase in calorie intake that accounts for that increase in body fatness. And we know if you take a person with obesity who's eating 30% more calories and you restrict their calorie intake by 30%, they start losing fat. So it's not a coincidence that they're eating more calories and they have higher body fatness. The higher calorie intake is causing the higher body fatness. But again, it requires that regulatory change in the brain that we can talk about. Because if you overfeed lean people, a lot of them will just burn off the extra calories. Okay, so that's one piece of it. The second piece of it is that you can feed people either excess calories or reduced calories, or you can keep them on maintenance diets, and you can feed them different amounts of carbohydrate and fat in those contexts. And what you find is that the amount of carbohydrate versus fat makes almost no difference to their body fatness. It's really the number of calories. So for example, if you overfeed people using only carbohydrate or only fat, you see the exact same amount of fat gain with the carbohydrate and the fat. If you underfeed people, you see very similar fat loss. So it really comes back down to the calories and not the carbohydrate or the fat. That said, I do need to note, and I think this is very important, that not everyone will gain the same amount of fat from the same number of calories overfed. So as I alluded to a moment ago, some people can take those extra calories and they'll just burn it off. Whereas other people, every single one of those extra calories will go straight into their fat tissue. And so that's one of the reasons why some people are fatter than others. Some people, if they overeat, it doesn't even make them fatter. I should say everyone will gain fat, but some people gain a lot less fat than others. So some people can just burn off most of the excess, whereas other people will store every single extra calorie. So it's more complicated than just calories, but it is ultimately driven by calories.
So about the research where if you overfeed people predominantly from increases in fat versus predominantly increases in carbohydrate, you see on average similar levels of fat gain. Does that then imply that a calorie is a calorie as far as weight and fat gain is concerned?
Yeah, to a close approximation, it does. And I know this is like the boring, unpopular thing that everyone wants to disprove, but it's the thing that has not been disproven by a number of studies to date. It just, the best evidence we have, I would say, is a meta-analysis that was conducted by Kevin Hall of metabolic ward studies. These are studies where they put people they put people in a research setting where they can absolutely control every morsel of food that's going into their mouths. And then they feed them different amounts of carbohydrate or fat, the same number of calories. And when you bring together all the studies that have done this, it's 20 studies so far, what you see is that it makes almost no difference whether people are eating carbohydrate versus fat when calories are held constant. And in fact, there was a difference. It was a statistically significant difference, but very small, that actually favored the carbohydrate. So eating the higher carbohydrate diet actually led to slightly less fat gain than eating the higher fat diet. But the difference is so small that effectively it's negligible. So, the idea of a calorie is not, yes, they're 100.000% identical in all scenarios. It's more like for all practical purposes, they're the same. So I just want to note, too, that I don't want to say that macronutrients don't matter at all. They do matter. Obviously, when people go on a low carbohydrate diet, they lose fat. When people go on a low fat diet, they tend to lose fat. So it's not that it doesn't matter in a real life scenario, but the mechanism by which it matters is that it reduces your calorie intake. It reduces your spontaneous calorie intake. So when you eliminate that effect in very tightly controlled conditions, you don't see any effect on body fatness. However, in real life, where calorie intake can vary freely, you do see a reduction in calorie intake and fat loss.
Right. I think one point that a lot of people, or a calorie skeptics get hung up on, is protein because of its thermic effect, which I think does have a small but yet still negligible effect when you measure it. What's your stance on protein, and is the thermic effect of protein enough to offset making all calories equivalent, essentially?
Yeah, it's an interesting question. And you would think, the thermic effect of protein is actually pretty substantial. Off the top of my head, it's something like 20 or 25% of the calories go away through this thermic effect. So it's actually a pretty substantial effect. And so you would expect it to have some effect on energy balance and body fatness, but when it's been tested empirically, it actually doesn't seem to make that big of a difference. And I don't know, maybe the experiments just haven't been sensitive enough, but what I've seen has suggested that it really doesn't seem to make that much of a difference.
I think that in really controlled metabolic ward type situations, it doesn't matter. But when you're in free living conditions, higher protein generally does work better even when calorie matched, just because of its satiety effect. But again, that's just affecting the energy in side of the equation. So it doesn't get you outside the rules.
Yeah, exactly. And protein is the most powerful macronutrient in that regard, in terms of its impact on calorie intake. So for me, if someone's asking me for advice on how to control their calorie intake and body composition, increasing protein intake is going to be one of the first things I say.
So just going back to the Hall paper, from what I remember, even though in the aggregate you saw no significant difference between increasing fats versus increasing carbs in terms of fat gain, actually you saw a slight difference in favor of increasing carbs, in that increasing carbs led to slightly less fat gain than increasing fats did. But still, on the individual level, you saw, I think, a lot of variability between individuals in the sense that some individuals seem to do maybe better with, restricting, or rather, they seem to do better with adding carbs, whereas others seem to do better with adding fats. So do you think that rather than maybe give the advice that it doesn't matter if you restrict fats or restrict carbs, maybe say, self-experiment and see what diet is going to allow you to restrict better?
Yeah, so there's two different things here. So the Hall meta-analysis didn't look at individual data, and I'm actually not familiar with the individual data that underlies the studies in that meta-analysis, but I'm sure if you looked at it, there would be variability. The question is that random error, or are some people actually responding differently? And I don't know the answer to that, but I would suspect that at least some component of it would be people responding differently. So it wouldn't surprise me at all if there were actually some individuals that, could eat the exact same number of calories from carbohydrate versus fat and gain different amounts of body fat. So, I don't think the research definitively demonstrates that there's no individuals where that might happen. What it says is that on average that doesn't happen, or at least doesn't happen to a large degree. But the second thing is what happens in the free living studies. And I think this is more relevant to what you're saying. So we have, for example, the Diet Fit study that was conducted by Chris Gardner's group at Stanford. In this study, they put people on low carbohydrate versus low fat diets. Neither diet was calorie controlled. In other words, they weren't asking people to eat a certain number of calories. It was just eat to satiety. Both diets were intended to be very healthy, so based on unrefined foods. The low-fat diet wasn't like a, SnackWell's type, SnackWell's and fruit juice diet. It was intended to be composed out of whole unrefined foods, and so was the low-carb diet. And what they found was at the end of a year, both groups lost approximately the same amount of weight in a free living situation. So I think the low-fat diet group lost 12 pounds, the low-carb diet group lost 13 pounds, and that was not even close to statistically significant, that difference between the two. But if you look at the individual responses, the spread was huge. And this is what you see in almost every study. The individual differences are much larger than the differences between interventions, the average differences between interventions. And so they did publish the individual data in this study, and you can look at those graphs. And on both diets, there were a few people who lost tons of weight, and then there were a few people who gained weight on both diets, but both of the graphs looked the same. So the distribution of people who gained versus lost looked the same. And if you average it all together, you get 12 or 13 pounds. But that doesn't, and again, we don't know. The thing is, it's complicated. You don't know why those people lost so much weight. You don't know why some of those people gained weight. Maybe the people who gained weight didn't do the diet, or they just started, eating really poorly all of a sudden. And just because they were randomized to that group doesn't mean they ate according to that group. And then the people who lost a ton of weight, I don't know, maybe they got cancer or something. So you don't really know why that happened. But on the other hand, I think it is at least plausible to speculate, and I think this is almost certainly true, that different people respond differently really do respond differently to those two different diets, and perhaps to a variety of different diets. And I mean, certainly anecdotally, this is true. You'll have people say, what you hear most often is you'll hear people say, hey, I tried a low-fat diet like they were recommending in the 1990s, and it really didn't do it for me. I was gaining weight, and then I tried low-carb, and it helped me out a lot, and now I'm not gaining weight. I also regularly get emails from people who say, I was on low-carb, and I read your work, and it allowed me to kind of realize that maybe the entire world doesn't revolve around low-carb, and I tried actually going low-fat, and it stopped my weight gain, and now I'm finally losing weight again. So there are people on both ends who I think just have better responses to one or the other. It's hard to say how much of it is biology versus how they're implementing the diets versus other stuff going on in their lives. But I mean, I would be willing to bet that there's at least some biology involved in that.
Yeah. So the one point is that different people might respond differently to either reducing fat in the diet or reducing carbohydrate in the diet. The other point is that even if you gave a bunch of people the same diet, you'd see very different levels of weight loss or weight gain as well. So how do you explain that? Why is it that some people get fat on 2,000, or let's say some people get fat on 3,000 calories and some people don't gain any weight at all?
Yeah, so there's a genetic component to that, definitely. So there have been studies done on this where they overfeed identical twins. So they get I forget exactly how many were involved, but this researcher, Claude Bouchard, did these studies. He got something like a dozen different pairs of identical twins, and then he overfed them. And what he found is that within pairs, they gained almost the exact same amount of weight, and they gained it in the same places. So if one twin gained 10 pounds and gained it in the belly, the other twin gained 10 pounds and gained it in the belly. So, however, when they compared across twins, what they saw was that it could be very different. So one pair of twins might have gained 10 pounds, the other pair might have gained 3 pounds. And, one gained it in the belly and the other pair gained it subcutaneous all over their bodies under the skin. So there's definitely a strong genetic component to that. And beyond that, we don't really know a whole lot about it, but essentially some people are able to upregulate their energy expenditure, their calorie expenditure, how many calories they're burning, and that burns off the excess fat. And I think, or the excess calories, I should say. And I think that probably relates to these systems in the brain that regulate body fatness. These systems, we know that they don't like you losing weight. That's why weight loss is hard. And they don't, in most people, they don't really like you gaining weight really fast either. So you see this in overfeeding studies where you give people a bunch of extra calories. A lot of people will start burning off the excess, and when you stop overfeeding them, their appetite goes down, and they basically go back to the weight they were before in just a couple of weeks. And so it's like this regulatory response that's trying to keep them at a stable weight. And we know a lot about the brain circuits that mediate this response. Yeah, so basically some people, you can think of it like a thermostat. You have this, so the thermostat in your house, it has a set point, right? So you might have your set point at 70 degrees. When the temperature goes below that, it kicks in the heat to bring you back up to 70. When it goes above that, it kicks on the AC to bring you back down to 70. It's called a negative feedback loop. It's a basic engineering term. We have tons of negative feedback loops in the body that regulate all sorts of things like temperature and blood pressure and a lot of different things. One of them is body fatness. And so when your body fatness starts to decline, you get all these compensatory mechanisms that kick in that collectively I call the starvation response. So your hunger goes up. It takes more food for you to feel full at a meal. You get more cravings. You're more reactive to food cues, and your metabolic rate goes down. Conversely, if you overeat a lot in a short period of time, you get a compensatory response in the other direction that helps protect you against fat gain. It's not perfect. You do gain some fat. But the key thing is that the thing that defends against fat gain, the mechanisms that defend against fat gain are not as effective and they're much more variable between individuals. So almost everyone will have a strong starvation response if they lose a lot of body fat, but some people will not have much of a response from gaining fat. So their body's like, I don't really care about that. Whereas if they were losing fat, it would care a lot, and you would get hungry and feel, tired and sluggish, etc. Yeah, so I think it relates probably to how our brains are wired in terms of how we respond to changes in energy balance. But we have a lot to learn about that, and there's very little that you can measure in a person beforehand that will tell you how they will respond to a calorie excess. So this is something that's been studied quite a bit. The only thing that I know of off the top of my head that has been shown to predict whether people will gain fat or not when they overeat is their level of physical fitness. So people who are more physically fit, that's correlated with a greater ability to burn off excess calories when you overconsume them. But it's an area that we really don't know a whole lot more about. I'm sure there's a lot of genetics behind it.
For sure. One thing that a few other guests, and I've talked about it on the channel a bit, is NEAT, so non-exercise activity thermogenesis. And it seems like some people, you could overfeed them by 1,000 calories, and they'll just fidget 1,000 extra calories off throughout the day, and it doesn't stick at all. Whereas other people will almost have all those 1,000 calories go straight into adipose.
Yeah, that's right. Yeah, and thanks for bringing that up, because that's another point that I didn't mention, but that's relevant. Yeah, that some studies have suggested that ability to burn off the extra calories is through NEAT, non-exercise activity thermogenesis, as you said, basically a fancy word for fidgeting. But I think it's important to emphasize, too, that this is non-conscious. It's not like people are like, oh, I'm overeating, I should fidget more and burn off more calories and, change my posture all the time. This is a non-conscious response that the brain is activating to maintain energy balance.
Yeah. You're not completely screwed, though, if you don't have this favorable NEAT adaptation response. Just, I feel like if you did make a conscious effort to move around a little bit more, do you think it would help you a bit?
Yeah,
it's
absolutely.
Better than not.
I mean, you could make a conscious decision to go for a jog or lift some weights. I mean, if you want to increase your energy expenditure, there are many ways that you could consciously choose to do so.
Yeah, it is funny though when people say, I think I'm going to, increase my NEAT, try to burn more calories. It's like, I think NEAT by definition, I'm not sure if this is true or not, but the way it's usually used in the literature is subconscious. But if you just spell out the acronym, it's anything that isn't formal exercise, but yet still burns calories.
Yeah, so I don't think the non-conscious aspect of it is part of the definition.
Right. So what I want to do is talk about obesity in particular. What is it about the brains of obese people that cause them to gain weight at a faster rate than non-obese people, essentially?
Yeah, that's a good question. And I think there are probably multiple reasons for this. So if we look at the genetics of obesity, what we see is that genes that make some people fatter than others tend to revolve around brain function. And some of those genes relate to the circuits that we have identified in my field that regulate body fatness. But I mean, if you think about it, there are a lot of different ways that brain activity could contribute to excess body fatness. You could either be wired to have a higher appetite. You could be wired to find food more seductive, more pleasurable, so you eat more of it. You could be wired to have less executive control, and so when you're feeling tempted, you have a hard time saying no. You could be wired to have a lower level of calorie expenditure, or your body fat regulatory circuits could be wired to give you a higher body fat set point or make it easier for an unhealthy diet and lifestyle to increase your set point over time. And so there are many potential paths to gaining fat, but I think which ones are most important in different individuals will probably vary.
Right. So what do you, because people will hear that and some people will think that you're just kind of in the totally wrong direction with this. And a lot of people I find, especially recently, are really quick to blame this on something very particular, such as sugar. Sugar is really a big culprit at the moment in the public consciousness. And I realized this when I did a video saying that sugar probably isn't the villain that everyone is making it out to be. I heard from all these people. I'm sure you have as well. So I actually think I'd like to hear your opinion on sugar and what role you think it plays in this whole equation.
Yeah, sure. So, first of all, I'm not a fan of refined sugar. I don't think anybody needs to be eating a lot of it. But I also don't think it's Beelzebub. I think that the recent focus on it is, in a sense, it's good. People are eating less sugar, but it's also a distraction because sugar is one factor in a more complex equation that's affecting our appetite and body fatness. And this is one of the things that I object to about Gary's perspective is essentially he is saying, and by the way, I'm not putting words in his mouth at all. This is quite literally what he argued very explicitly in the case against sugar, that only sugar matters, or it's overwhelmingly the primary determinant of obesity and chronic disease, and that calorie intake, physical activity, and dietary fat intake are basically irrelevant. So that, I think, is a dangerous perspective because it's saying it's putting all of the focus on one factor and taking all of the focus away from these other factors that actually do matter, especially when it comes to health. So, the issue with sugar is that it is refined. It's an empty calorie because of the high level of fructose it contains and the fact that fructose is metabolized almost exclusively in the liver. It overloads the liver with energy and can promote liver insulin resistance and metabolic abnormalities. And that's actually an area that Gary and I at least partially agree on. Sugar does have some harmful effects that are independent of its calorie intake, but those seem to manifest at higher levels of intake. putting a couple teaspoons of sugar in your coffee is really not going to cause that to happen. But I think for me, the biggest deal with sugar is it just makes us eat more. Sugar tastes great. So you put it on foods, it contains calories, it increases the seductiveness of those foods. I mean, think about, ice cream, for example. Ice cream, to me, is one of the absolute most seductive foods. Like, for me, it's almost drug-like eating ice cream, how amazing it tastes. But what is ice cream without sweetness? It probably would taste good, sure, but you're not going to eat hundreds of calories of it after a large meal. And same for if you remove the fat. If it was completely fat-free ice cream, you probably wouldn't want to eat that after a large meal, at least for me, the fat and the sugar together is really the combination that is where it's at. But yeah, I guess what I would say is I'm not here to argue that sugar is harmless, but what I am here to argue is that there are other things that matter too. And so, for example, if we look at physical activity has a huge effect on insulin sensitivity. And insulin sensitivity is one of the primary drivers of chronic disease risk, especially diabetes, but also cardiovascular disease, possibly cancer, and a wide variety of other common ailments. So, if you think that insulin resistance matters, if you think that diabetes risk matters, then you should be getting physical activity on most days. And the evidence is very clear on this. If you look at athletes, they have very high insulin sensitivity. If you take those same athletes with high insulin sensitivity and you make them sedentary for 10 days, suddenly their insulin sensitivity drops quite a bit. And then similarly, you take someone who's sedentary and get them to exercise more and their insulin sensitivity goes up. Furthermore, we have large, huge, well-conducted, multi-year, randomized controlled trials showing that increasing levels of exercise prevents the occurrence of diabetes. So I'm not talking about biomarkers. I'm not talking about animal studies. I'm talking about randomized controlled trials with real diabetes endpoints showing that exercise can reduce the risk by something like 45 to 75%. So huge effects. And you see the same thing with dietary fat. You put people on a drug called orlistat that reduces dietary fat absorption in the gut by 30%. So it's not even that large of a change in dietary fat absorption. Well, that reduces diabetes risk by a lot. It's something like 35 or 45%. I don't remember the exact figure, something in that range. And then you can give people acarbose, which reduces carbohydrate absorption, and you see something very similar. So any way that you affect energy balance, whether it's through physical activity or reducing fat intake or reducing carbohydrate intake or just an overall low-calorie diet, these things have all been tested in large, well-conducted, years-long randomized controlled trials with real diabetes endpoints, and they all reduce diabetes risk. And so anything you do that affects your energy balance such that you're taking in less energy and you're losing fat, even if it's not a lot of loss, even if you're not losing a lot of fat, that is enough to substantially protect against diabetes. And so I just want people to know the full picture. I don't want them to eat more sugar. I don't want them to stop restricting their sugar intake, at least refined sugar. But I just want them to know that it's not just about sugar. There are these other really, really important factors out there that you should understand and you should be leveraging if you want the best effectiveness that you can get.
Mm-hmm. I think when it comes to insulin resistance and avoiding diabetes, the best things you can do are live an active, healthy lifestyle, like you said, and maintain a good body composition, and then pick the right parents, because that genetics play a big role there as well. Whereas I feel like many people in the mainstream public sphere would say that you should reduce sugar, because reducing sugar is a good idea if you have diabetes, but doesn't necessarily mean it's independently causative of it. Would you agree?
It may be independently causative to some degree. I mean, in the sense that it can increase liver insulin resistance in a manner that's at least somewhat independent of its calorie value. So I don't want to say it's completely dependent on, its calorie value and the body fatness that the fact that it increases our calorie intake and body fatness. But I would say that I have little doubt that the primary causes of diabetes, just to put it simply, are excess body fatness, physical inactivity, and genetics. I think if you look at the overall picture, that's what the literature suggests. And is sugar playing some role independently of those factors? Yeah, could be a little bit, but I think that those are really the biggies.
Mm-hmm. Fair. Getting back to sugar and obesity, I noticed on Rogan's podcast you showed, I think, some NHANES data basically showing that sugar rates have just dropped off progressively since the 80s or 90s, but yet obesity rates have increased since then. So it's clear that they're actually not even correlated, let alone causally related. That was a similar case that I made in my video, except I used Australia. The same exact trend you see the exact same trend over there. How can people not acknowledge that? I mean, if they're not even correlated, if one is going down and one is going up, how can you still make the case that sugar is the main factor?
Yeah, I think it becomes pretty difficult, but people have found a number of ways to continue believing what they want to believe. So Gary has argued maybe there's a threshold effect. If you get above a certain amount, then beyond that it doesn't matter. Or maybe there's an intergenerational effect where we're actually experiencing the negative effects of our grandmothers or mothers eating sugar, and so it doesn't really matter how much we're eating. Some people would say, well, maybe the people who are reducing sugar intake are the people who are lean anyway, and it's, the people who have obesity are eating the same amount. These are all ideas that I'm not aware of any evidence to support. But there are ways that people have kind of continued believing what they want to believe. But I think that the more important thing is, it's not an ironclad piece of evidence, seeing that sugar has gone down by 15 to 23% since 1999 in the U.S. and seeing that obesity has gone up. It's not an ironclad piece of evidence. I'll agree with that. But I would say that it's a fairly strong piece of evidence, especially when considered in the context of all the other evidence pointing in the same direction. For example, like you mentioned, similar trends happening in another number of other countries. There's Australia, there's the UK. Sugar intake's been going down for about half a century in the UK. It's gone down by about 22%. And that covers the entire period of the obesity epidemic in the UK. So, I mean, and then there's other evidence from other lines of investigation. And you put it all together and you can either have a really complicated hypothesis that explains away all these things that don't, conform to your model, or you can have a really simple model that says that sugar is not the primary cause of fat gain, and then everything makes sense. So that's kind of my perspective on it. But, I also want to emphasize that the fact that sugar and obesity are going in the opposite direction right now, that doesn't mean that sugar is not involved in causing obesity. Because if your model is that sugar is a factor among other factors, then you don't necessarily expect to see a great correlation, because there could be other things changing that confound that. What it really refutes is more the idea that sugar is the primary cause of obesity. If sugar is the primary cause, there's got to be a correlation, or else that's pretty tough to explain with the model.
Yeah. So I've got two other questions for you, and then we'll wrap it up. The first is, especially given your extensive background in neuroscience, what's your opinion on sugar's addictive qualities? You talked about how people tend to overconsume on it. Would you go as far as to say it's addictive?
Yeah, I mean, I think there are certain foods. It's tough. It's controversial whether or not we can apply the word addiction to foods in the strict sense of how the research community and the medical communities would use the word addiction. That has a pretty strict definition, but I think it's clear it's absolutely clear that some people have addictive-like behaviors that they use around certain foods. And so some people's eating behavior in regard to certain types of foods is certainly addiction-like. It looks a lot like the types of behaviors that someone would have around an addictive drug or gambling problem or something like that. And so I think everybody agrees on that in the research community, that whether or not you can truly call it addiction, you can at least call it addiction-like behavior. Now, what types of foods does this apply to? The most common foods that drive addiction-like behaviors when they survey people, and these are very similar to the foods that people report craving the most. Addiction is basically a strong craving. The foods that people report having addiction-like behaviors toward and cravings toward the most are generally combinations of carbohydrate and fat. Some of those will contain sugar and fat like ice cream or baked goods. Chocolate is actually the most commonly craved food. And then also savory foods that don't contain sugar, but maybe they do contain carbohydrate and fat. Things like French fries and pizza, those are also really commonly craved. Popcorn and savory snacks of that nature. And so when we look at the commonality here, what we see is not sugar. What we see is the combination of carbohydrate and fat, especially when you throw in some other things that spike our dopamine, like salt and glutamate, which is that umami flavor, and nice textures and flavors and things like that. So that's really where it's at as far as the brain is concerned, and those are the foods that really drive addiction or addiction-like behaviors and very strong cravings that are hard to control. And it's really all about dopamine. These are foods that have properties that spike dopamine in the brain very strongly. And probably the reason why chocolate is the most commonly craved food is that not only does it have a lot of fat and a lot of sugar, it also contains a drug called theobromine that activates the dopamine system in the brain. And so you have this convergence of all these different factors in chocolate that really get the dopamine going and drive heightened motivational states toward eating. And, if your motivational state is strong enough, we call it addiction. That's really what addiction is. It's a result of dopamine spiking too much in the brain, too much motivation. You prioritize those behaviors too highly, and it causes harmful effects in your life. And so to get back around to your question, is sugar addictive? I would say that sugar is part of the picture of foods that stimulate us too much. I think colloquially, sure, we could call that addiction. Whether you would really diagnose it as addiction in a clinical sense is controversial. I would say probably yes for some people, but that's my opinion. But are you going to sit there and be addicted to a bowl of sugar on your table if it's just plain sugar? No. If you look at the studies, foods that are just high in sugar and not high in fat and other things, some people do have addiction-like behaviors toward those things, but it's a lot less common than the types of foods that I was talking about earlier, like chocolate and pizza and ice cream, and the things that are really not just sugar. They're combining together different dopamine spiking nutrients.
Mm-hmm. Yeah, I think that's really well said. I pretty much totally agree with you on that one, as most of the points you've made. So to kind of wrap this up, what would be your, say, main takeaway? Like for someone who maybe has this predisposition toward fat gain, they may be overweight, and there's all of this noise out there, and it's hard to know exactly what to latch onto. What do you think is the most important thing for avoiding obesity, maintaining a healthy body weight, et cetera? What's your kind of main finishing package?
Yeah, so the first thing I would say is that, don't beat yourself up. We have 75% of differences in body fatness in a country like the modern US are attributable to genetic differences. Different people are dealt a different hand in terms of their challenges in life, and one of the ways in which we're dealt different hands is in how hard it is for us to keep our body fat level down. And that relates in large part to how your brain is wired, but it's not necessarily about conscious choices that you're making. A lot of it is non-conscious brain activity that sets your appetite and your cravings and how you respond to food cues and many other things. So these are, non-conscious brain circuits that we inherited from our ancestors that are not designed for the modern world. And they're doing what they're supposed to do. They're doing what they evolved to do. It's just not playing well with the modern food environment and the modern lifestyle environment. So that's the first thing, is just don't beat yourself up. Just understand that this is your body and your brain that's just designed to do this, but it's just not really playing well with the environment that you find yourself in. But at the same time, you have to try to find some kind of solution for that if you want to control your body composition, if you're someone who is susceptible to fat gain. And so I think the first thing that it's really important to do is to control your food environment. So the brain is very reactive to what's in our environment. And once you've eaten a food and you've got your dopamine spiking, the next time you encounter cues that remind your brain of that food, whether it's the sight or the smell, or even just knowing it's in your closet, those things will get your dopamine spiking again and will put you back into that motivational state that you're going to have to struggle against. So it's really important to have a supportive food environment around you, both at home and at work. You don't want to have tempting foods on the counter. You don't want to have anything, especially you don't want to have anything visible that's not a food that is supporting your goals. So you don't want to have tempting things. So for example, in my kitchen, I've got raw, fresh fruit, usually something you have to peel, like a banana or an orange. So there's a little work, there's a little effort barrier involved. Peanuts in the shells that are unsalted. So it's not like that tempting. If I'm hungry, yeah, I'll eat unsalted peanuts. But if I'm not hungry, I won't eat it. And I have to work a little bit for it. I have to shell those peanuts. So that's just some ideas. If you walk into my kitchen, there's not like cookies or soda or really any kind of tempting food on the counter or visible anywhere. And there's not a ton of snack food in general. So controlling your food environment, I think, is really, really important. Not only does it make it harder for you to deviate from the foods that support you, but you actually won't even crave those foods. You won't want them as much because your brain non-consciously understands that they aren't even available. So that craving will not even be generated in most instances. And so that's one thing. Second thing I think is really helpful is just eating a simple whole food diet, eating food that's more similar to how our ancestors ate, unrefined, lower calorie density foods. So you're avoiding refined flours, and I would say flour foods in general, probably not a bad idea to avoid if you're trying to control your body composition. Added sugars, added fats. You want to get your carbohydrates and your fats and your proteins from whole foods that you're making from single ingredients in your kitchen. And, not necessarily getting fancy and trying to make it all delicious, but just eating these very simple whole foods like our ancestors would eat. And that has some properties like increased satiety and more moderate palatability that helps us regulate our calorie intake more effectively and feel satisfied with fewer calories. Another thing I would say is increase your protein intake. That's kind of a no-brainer. It helps reduce your calorie intake and it helps support your muscle mass as you're losing body fat. Another thing that I would say is to get regular physical activity and try to get plenty of sleep and regulate your level of stress. And then finally, I don't want to leave out, because I know some people find this effective, is you can also consider reducing your carbohydrate intake or reducing your fat intake if those other strategies haven't worked for you. So if you're eating a whole food diet and you're exercising regularly and you're eating a higher protein, lower calorie density diet, and it's just not quite getting there to getting you to your goal, then you could consider adding on that extra level of carbohydrate restriction or fat restriction.
Yeah, I absolutely love that answer. And it's really refreshing to hear, because in my corner of the internet, a lot of people will focus, I think, almost reductively on tracking your calories, track your macros. As you kind of said at the beginning, people in these like almost obsessive fitness spheres tend to really get very analytical with it and then project that onto people who might not want to track calories or macros or whatever. So I think that, hell, even people who are really obsessed with going to the gym, having this focus on not only the calories, but also the types of foods that you're eating is important, because it might be a really simple way for you to just modify your behavior and eat a better diet as a result without having all the extra steps. So I really like that. On your last point of reducing carbs or fats, one thing I've recommended in the past was, it's kind of weird, but alternating carbs and fats meal to meal, so you never combine them, because it's when, as you said, when you combine them, the foods just start to taste so much better and you're so much likely to go back for a bigger serving. So it just splitting them out doesn't do anything magical from like an insulin perspective, but it just will help you eat less almost automatically. Anyway, Stephan, it's been a great chat. I'd love to chat again sometime. Maybe we could go more down the rabbit hole of like the brain circuit stuff in a little more detail if the people would like to hear that. But I really appreciate your time. I know you're a busy guy, and maybe you can let people know where they can find you. Oh, I was going to say one thing. I actually meant to say this at the beginning. In the Joe Rogan debate, you talked about how you had a reference list on your website of so as you were going through your points, you were kind of referring people to like reference 24 or whatever. And I think you really underplayed your reference list, because it's not just, I was expecting it to be like number and the name of the study, but it's a summary of everything with multiple references in each bullet point. So it's almost like a wiki of everything you've talked about. So it's a fantastic resource, and I'll have that linked below if people would like to check it out. But other than that, where is it people can find more from you?
Yeah, I appreciate that. Yeah, there's probably a couple hundred references in that post. Yeah, it's on my website, stephanguyenet.com. Or if you don't feel like spelling my name, it's wholehealthsource.org. That'll take you to the same place. My book is The Hungry Brain, and that is a general audience book on the neuroscience of overeating and body fatness. And I'm pretty active on Twitter. My Twitter handle is @WHSource. And one last thing I want to tell people about is a new organization/website that I just created. It's called Red Pen Reviews. And we post the most informative, consistent, and unbiased health and nutrition book reviews that you can find anywhere.
Awesome. I'll look forward to checking that out. And yeah, for anyone listening, I'll have all of the relevant links down below, including the studies that we talked about, and I'll have that full database that you've got on your website there as well. So thanks again so much for your time. For everybody listening, don't forget to leave me a thumbs up if you enjoyed the video, subscribe if you haven't already, and I'll see you guys next time.